Okay, so we're going to keep talking a little bit more about mean and median and what we should use in what situation here. So let's suppose you're looking for a house and you want to spend about $250,000. So, you've narrowed it down to two different neighborhoods. Neighborhood A, you found it has 10 houses in the neighborhood and they're all right about $250,000. So you can definitely afford something in that neighborhood. So if we think about it, the median in there, if all the houses are about $250,000, the median is going to be somewhere in that range too, right? We might have, it might be 240, 245, 255, somewhere in there, but we're just calling around numbers here. The mean, also going to be about $250,000. So the mean and the median are going to be pretty close to the same in this neighborhood. Either one of these measures of center, the median or the mean, could be used to describe the prices of the houses in neighborhood A. Now let's imagine neighborhood B, which is very similar, but someone took one of those 10 houses that were about $250,000 and they built $1 million house. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 houses that are all about $250,000, and then our $1 million house way over here, right? So the house that's in the middle, physically in the middle of the data set, is still somewhere in that $250,000, right around there, price point, right? So I've got my median, there's 10 houses, so I've got 5 houses that are $250,000 or less, and I've got 4 houses that are $250,000 or more, and one that's $1 million. But then the mean, if I take those 9 houses that are $250,000 and the one house that's $1 million, and I add up all those prices and I divide by the 10 houses, I'm going to get a mean that's about $325,000. So if your realtor just said, hey, neighborhood B has got an average price of, and she used the mean, $325,000, you would say, don't even bother. That's out of my price point. That's way too much money for me to be spending. So in this case, where we have an outlier in our data set, the mean is no longer really representative, because really there's 9 houses in that neighborhood that you could afford. So in this case, they're not representative. I think I've left out a few letters. Not representative of the prices in that neighborhood. So, and that's because the outlier in this case will say pulls the mean value up. All right, so in this case where we have an outlier, our median is going to be the better choice. It's more representative of the values. It's what we might say is a typical value in the data set. So the median would be the better choice in that situation. Okay, so when are the mean and the median of the data set going to be the same or close to the same? That's going to happen when the distribution is symmetric. So when the histogram looks roughly symmetric, you should expect your mean and median to be roughly the same. Okay? So having similar values between the mean and the median is actually a characteristic of a symmetric data set. Now on the flip side, if our distribution is skewed or it has outliers, our mean is going to get pulled towards the tail or pulled towards the outliers because, remember, the mean takes into account the values of all of the data values. So we're getting more large data values, right? And that's going to increase the value of the mean, or if it's skewed to the right, or it's going to decrease the value if it's skewed to the left, versus the median, which simply cares, do I have half the data values below me and half the data values above me, right? So we're going to look at two different data sets. One is I had my students bring in a bunch of pennies So this is the last time I taught a face-to-face class. And we're going to make, first off, a histogram. You always want to do that first. So this, I think you can find this in D2L under Content, Statistics Resources, and then there's a link for data files. And you should be able to find, I think this is Spring 2019 pennies. And I just had everybody brought in about 10 of them, and they recorded the year for each penny, and I compiled all the data. So we're going to select year for our variable. You can hit select. I want it twice in there. I did it twice. And we're going to hit OK. And that's going to bring up our histogram here. All right. Now, so you can see this is roughly unimodal. Very definitely skewed to the left because we have our mode up here in the 2015, give or take, but we have lots of data values in 1980, 1970, so on and so forth. We even potentially have a potential outlier down here at, well, I say potential because I think it's a typo. I think somebody misread the 1985 as 1935, but maybe it was. In the histogram, that is definitely an outlier. So that's what we're looking like. Now, how do we get up? There's like a boatload of data values in here. We are not hand calculating the mean, so we're going to have software do it. So we're going to go to Stat, because that seems like a good place to get statistics, Basic Statistics, and then Display Descriptive Statistics. And you're going to select the one you want. In this case, we're doing year. So I'm going to hit Select, and then I'm just going to hit OK. Later on, you can hit the statistics button here, and it'll give you all the ones that that you could want, but we'll just go with the defaults. So what that's going to do is going to let you know, okay, we've got 440 data values. We've got a mean of 203.2. Some of these other things we'll talk about later, and then the median 2007.5. So you can see the mean. This is less skewed. We expect the mean to be lower, and it is. All right. So how do we do that with GeoGebra? So I'm going to pull this up. I've got, this is the online GeoGebra, and I'm pulling my penny data, spring 2019, and we're going to see if this crashes the computer. Because it is a large data set, and GeoGebra does not always like those. So go to Spreadsheet. We're going to try this again. I may have to go to the local version. So one thing, when you're doing GeoGebra, if it's not specifically a GeoGebra file, you may have to go click All Files instead. And let's see, penny data, spring 2019. That's an Excel file. It should open, but I do think it's a little too big for this one, which is one of the problems with GeoGebra. So let me try the local version real quick. So we're going to do the same thing. I'm going to switch over to spreadsheet view, and I'm going to go to File, Open, Local File, and I'm going to find where I saved it. And all files. So penny data, spring. I've got a bunch of these. They all should be roughly the same. They're spring 2019. Okay. And you can see that it is struggling with it as well. So this is one of the reasons why I want you to know both of the options. All right. So we'll do this with a smaller data set sometime, but we're going to leave this alone for now. All right. So the other one I wanted to show you was Clayton State salaries, because every time I teach this, I like saying, okay, what do you think the average pay is for Clayton State? And people are always kind of surprised. They give a much higher value than you would think. And I'm like, okay, so this, I pulled this from Department of Audits, and I'll get this uploaded if it's not already there. So this is everybody who got paid, everybody who worked for Clayton State in any capacity in 2022. This was the most recent data available at the time that I did this video. So we're going to hit OK. And we're going to do the same thing. We're going to make a histogram. This is salary and travel money, but we're just going to look at salary. So we're going to do histogram, simple. We're going to do salary. Now, so I want you to think about it. What do you think it's going to look like? Because almost all the time, my students, unless you've been out working in the real world for a while, they're going to say, I think it's skewed to the left. And I'm going to say, that's not right. Because this is including not only your professors and your administration, but your custodians and your part-time instructors and your student workers, okay? And we have a lot of those. So we're going to hit OK here. And this is, let's double click that so it'll come out. This is our histogram of our salaries. So you can see we have a lot of student workers. Here in the 40 to 80s is almost all of your professors. And then you start getting into your department chairs, your administration. You know what, in here in the 80s to 120s is computer science and business faculty also. And your nursing, I think they get paid pretty well too. So this one, unimodal skewed to the right. And if we do the statistics on it, so we do stat, basic statistics, display descriptive statistics for salary, we're going to see what is our mean. Let's see, I got to get rid of this. Our mean pay is $37,395, but our median is only $23,486. So that's over $10,000 higher mean than median because of that skewness. All right. So we're going to leave this here, and we'll be back with variability.